Hello, I'm Daniel, aka Second Interval, and today I'm gonna show you what I have developed with the help of Chord, but still developed, is a MIDI router based on Raspberry and under the hood Python. And you already see my setup here. I have quite a bunch of sequences, synthesizers, and instruments, an Octatrack, a Digitone, and a launch control, and a keyboard, of course. This is a simple keyboard, MIDI keyboard, and the Roland S1 as a tone generator. And what I have done is I've created a small pattern here, which sounds like this. Nothing special. However, the magic comes in with the Raspberry Pi, which is over here, and all the instruments you can see here are connected with USB MIDI. Of course, not the Octatrack, because Octatrack can't do USB MIDI, but the Octatrack is routed through the launch control. This is a nice thing, since the upgrade you can put USB MIDI in, and the out ports can be mapped then to whatever uses DIN MIDI. This is on the USB port, and the MIDI goes into the Octatrack here in the MIDI in. So right now, as you can see, nothing is playing, the Octatrack isn't working. This is because nothing is routed right here. This is the routing you can see here, the routing matrix. And what you see here are two blinking orange lights, and this is because the S1 is sending clock and the Digitone is sending clock, which is actually no problem. I think I can play here. Where's the play here? Yeah, nothing happens because there's no pattern. But both are sending clocks into the Raspberry, into the RaspiMIDIHub. This is the name of the project. But the S1 is clever because it knows that as soon as it receives clock, it shouldn't send clock, of course, because there must be only one clock source in the MIDI routing. And this means as soon as I connect the Digitone, which is on this column, which is the from column, and here's the to row, and as soon as I connect the Digitone to the S1, which is here, the S1 will stop the clock. Yeah, it stopped now, and the Digitone is blinking green. So right now I can already send MIDI from the Digitone to the S1, which is here on the number 15. Yeah, and you can hear the S1 already. And this is all the magic. There's a lot more in this, and this is what I'm going to show you today. The routing, the mappings, and things like that. So let's start. So here I have a keyboard, and if I hammer on the keyboard, you see the green bar here raising, because this is the amount of MIDI data it's sending. So it's the Impact GX49P1. Port 1, and I can click on this instrument, and also here I got a MIDI debugger. So as soon as I hit some notes here or turn the mod wheel, you see that the debugger outputs whatever comes in. So what I can do now is, of course, just, which one was it? P1 map the P1 to the Digitone like this, choose an instrument, that one, and I can play it. So this is on the auto channel. The Nectar here is playing on channel 16, I think, is my auto channel on the Digitone. So whatever instrument I choose on the Digitone, I can play now. Right. I just saw that there's bit much gain on my microphone. So let's fix this. Okay. So. And this is already cool. Now I have my launch control here, which is a MIDI controller. And this also sends to, as you can see on the green bar here, this is also sending to the MIDI port. So the launch control XL3 P1 is the port that sends to the USB MIDI. And I can map this, of course, to the Digitone, like this. But nothing happens. So let's have a look at the instrument and into the MIDI debugger, and we see it's sending on channel 2 CC5 for this fader. And if I want to map this, because what I need here is I think channel 3 CC1 for the mod wheel and CC2 for the breath. And I'm gonna map this to CC1 and this to CC2. So I have, actually it's that one. This is number 3, 2, 1, 3. That one to CC1 and that one to CC2 on this specific instrument and channel. And for this, I can long hold or long tap, or in the browser you can right click on this exact mapping, which is sending, let me show you again, from the Launch Control XL3 to the Digitone. And if I tap on this connection, first of all, I can of course filter the MIDI channels that I want to receive or transmit in this channel. Then I can filter the message types, and the mapping is here. And for the mapping, I can map nodes to CC, which means I can tap a node and this sends a CC, like send the node C3 will destination CC1 and values for whatever, how hard I hit the node. I can do the same with toggle, like on off, like for mute states, if you want the last 8 nodes for mute states. And I can map CC to CC, and I just can remap channels, which is also sometimes nice. And I have this MIDI Learn, and when I press this and move the fader, it already recognizes that this will be a CC to CC mapping. And it is, we have source channel 2 on this fader and CC7. And I need this on destination channel 3, for example, CC1. And let's hear it. No, nothing happens. Okay, I think I need the destination channel 16 just because it's my audio channel. And of course, I have to click add. Yeah, we can hear this already. Great, great, great. Now let's map the second fader. So I can just add another mapping on this connection, or also use the MIDI Learn, which is this one, right? So destination channel will also be 16. Yeah, they are. These are beautiful UI elements. And I have the source channel for this knob. Of course, I could program the launch control, but why do that? And the destination CC will be 2. I also can limit the input min and max, like just map, I don't know, 64 to 127. And do another mapping for the lower part, like different types of filters or whatever. And I can map the out mapping, which means for the Digitone, for example, there's a nice feature. I think it was set up sometimes down, and here's the mod wheel. This one can map one mod wheel to 4 parameters. As you can see here, it's mapping this. If your instrument cannot do that, you can of course map the single CC to multiple outputs, and of course then limit the min and max, like just go like for the cutoff, just for 90 to 100 or something, to add a bit of grain into the sound. So now we have this knob here that I want to turn, and you see the source channel 2 and CC31, and I'll map this to channel 16, which is actually not okay. I think we will stick with channel 3, and I'll edit the other one too. Destination 2, I'll add this, edit the other one because I also want channel 3 here. Save this, and now a short and long. And the modulation wheel. So that means we can map whatever we want. Also, of course, I can do this for each mapping that exists. Right now, I have mapped this. So maybe I just play something. Well, is this muted? Yeah, sure. There was already something there. Okay, and it doesn't matter, let it play. And now, even if I switch the channel, of course, I now have the expression here. And this is what the mapping does for me. So this is one possibility that I can do here. Of course, I can map anything to the S1. now you can hear the S1, and this goes through the Digitone 2 on the mapping channel through the MIDI into the S1. Of course, it's mapped still just from the Nectar Impact here to the Digitone. But let's say I want a virtual instrument, and you can see 3 configured virtual instruments up here. They always appear on the top and are in a different color. I can add, of course, anything I'm looking for: CC LFOs, CC smoother if you have a bad MIDI controller and this needs some smoothing. Chord generator, of course, master clock, which is already in my Digitone. I don't need that. MIDI delay is just an effects, like if you hit, you can hear this now. This is an acoustic delay, but this also works with the MIDI delay. Note splitter, where you can split your keyboard and stuff like that. So there are many virtual devices you can use, and one of them is the Arpeggiator. So if I just use the impact here, disconnect it from the Digitone, and connect it to the ARP, which is, which one was it? That one. Here, from the impact to the ARP, which you still don't hear anything, because I need to connect the ARP now to the Digitone. Now you can hear it, and if I'm going into the ARP here, then you can see I have several options in the ARP, like note length. And this is already synced to clock, so I can have different ARP steps here, like, I don't know, 8 maybe. I have an accent velocity, which we'll play with in a minute, like let's make like something about 70. And I can define each note with an offset. So if I don't do this and just use the ARP, then I still have 3 octaves here. Let's make it 1. So this is a stupid ARP. So if I hit 2 notes or 3 notes, this is exactly what an ARP does. But I can add values here, like this note here, for example. Don't do this. Use that one. Come on. No, of course, it's when shown it bugs. Now you hear the +7. And this is already pretty great, because if I now add the octaves, I can make some beautiful stuff like that. I'll just move the mobile a bit here. This is where I have it here. Now this is beautiful already. And you can, of course, go up to 32 steps, which is just a virtual limitation, nothing special. But you can also go down to like 5. And 5 steps with 3 octaves makes this complex, beautiful thing, which sounds like that. Oh, I love this. Beautiful. And let's add a note splitter. So I can play the bass with it. So I'm just adding a note splitter now, and the impact will now not enter the arpeggiator, but the note splitter, and the note splitter, which the impact has to go to the note splitter, and the note splitter goes to the ARP. And you already can hear 2 instruments here. So if I long tap this, of course this is just the usual mapping. And if I go to the note splitter, of course you can have many note splitters, as many virtual instruments as you want. You just have to wire them. Then I have the lower zone on channel 1, which is the bass. This is beautiful. And I have the upper zone, which is channel 3. Energy save. No, not now. And here it is. And right now I have the arpeggiator, of course, also here. So if we... which I don't want, I just want it here, and actually I want this an octave down. So I go back to the note splitter and use a transpose for the upper zone, which goes 12 half tones down. Yeah, beautiful. And also I will not send channel 1 to the ARP. Instead, I'm connecting the note splitter to the Digitone directly, and for this connection I will just send channel 1, so I turn off all the others, like this. I have to scale this up a bit, or I have to move my phone, and I don't want that. Make it +12. Yes. Now. Yeah, this is the note splitter. So the other thing we can do is, if I'm playing the arpeggiator here, this is just a +7. Of course I can hit multiple notes for the arp, and if I just transpose this, this will not work. So maybe, I don't know, like here. This is not the same scale, this is just bad. So what I can do is I have the scale remapper and the chord generator. And let's just enter the note splitter, so the upper part, which goes now to the arp. Don't send this to the arp, send this to the chord generator. Also only channel 1, so we turn off all the others, like this. No, sorry, not channel 1, exactly not, all the others are on. I'm wrong. So now, doesn't work of course, because the chord generator doesn't send to the arp, but we can change this. And now the chord generator, which is just a simple, let's disconnect this and send the chord generator is sent now to the arp. Let's send it just to the Digitone. And this is what it does. And I don't like this because this is the wrong scale. And for this I have the scale remapper. So let's just send it from the chord generator to the scale remapper and from the scale remapper to the Digitone. And now let's configure the scale remapper, which is already at D minor. This is good. Go down. And you can already hear it in action. And now we can just send the note splitter not directly, not the chord generator, to the scale remapper, and the scale remapper not to the Digitone, but instead send the scale remapper to the arp, which is sent to the Digitone. And now we have a perfectly mapped scale. This is beautiful, I think. So we have many more options here, many more instruments, many more possibilities to route and everything. And I've shown you just the beginning. We can save presets here, like, yeah, this is my so-called coffer, but I can A, B, C, add another preset here. Don't forget the Raspberry Pi is mounted in read-only mode, which means you can always plug it off. It won't matter. Nothing will crash or something. You don't have to shut it down, nothing. It's just pull the plug and it's all okay. But you need to save the config explicitly. So this will save all the routing here, the mappings, also the presets and everything. And this is just for the end of this video. This is the settings screen where you can just see a few data things from your Raspberry Pi. The Raspi does open a access point with a default password. You just connect to it and have this IP address, which you can connect with your browser on your phone. This is not an app. You just open a browser and connect to this IP address, and it just works with all these UI elements and this sexy interface, I think, at least. Of course, you can change in the AP settings the password. You can also join your local Wi-Fi. Then you have to find out the IP address in some way. There's an explanation in the documentation for this on RaspiMIDIHub.com. From where you can link to, or from where it's linked to GitHub, where all the documentation is. This is all open source, by the way, LGPL, so you can do whatever you want with this and install it on as many devices as you like. Also, you can configure the Ethernet address, which I have just done because from this is where I get my internet from. And the internet helps. There's a default on MIDI routing where you can say if usually you want to connect all if you plug something in, or disconnect all. This is of course hot pluggable. You get the MIDI activity bar, which is this here. This is a default debugger, and you can disable this if you don't like it. I love it because I always see what's happening in ARP is sending notes and stuff like that. This is beautiful. Also, this is an online update. Which means as soon as your Raspberry Pi has internet, you just click on install the new version, and the new version is installed. Give it some time. It doesn't need reboot. The reboot here is only for debugging. Installation is for us tech nerds, is a Debian file download and an apt install, nothing more, nothing fancy. You can of course always read the changelog, what changed from your version, and you can get older versions too and install them if you need. So, and there's a reload app, because if you open this in a browser, you get an install this as an app button here, which essentially is a browser, but full screen. So this doesn't have a reload button. So if you need to reload at some point, maybe if you reconnect the Wi-Fi or something, you can do this and it's just reloaded, like the reload button on the browser. And for last, the Reboot Pi. So this is it. If you click install, it's just taking about a minute. This is best tested and running on a Raspberry Pi 3B, I think is what I currently have. I'm right now testing it on a Raspberry 4 that I just got hands on. For the Raspberry Pi 2, it should handle the load, of course, because as you can see, the load is not, even if I play a lot of things, the load will rise to like 0.4 or something on this model. So the 2 should also handle the load, but the Raspberry Pi 2, I think, does not have Wi-Fi, which makes this all a bit more cumbersome, and you need the Ethernet and a desktop browser maybe, which all works, but this is, I think, a lot more sexy. So again, I'm Second Interval. I have created this for you. I hope you enjoy it and wish you a nice time with it. Have fun and tell me, and maybe give a star on GitHub and thumbs up here on YouTube. Thank you. Bye-bye.